Hi guys, thanks for the great introduction, Cindy. And I hope you can hear me clearly. I'm going to talk today about intermediate Linux, which is always an important thing. Once you learn the basics, then you need to learn a few more skills and uh, tasks that you can do to be able to navigate your computational workloads more effectively. Okay, so this is a talk that's part of the Complex project. Complex stands for Comprehensive Learning for End Users to Effectively Utilize Cyber Infrastructure. It's been around for a couple of years now, where I think we're in year 3. And the idea is to present our users with topics that they need to get started in HPC. We've always had a program where we do this baseline HPC training, and now Complex is featuring a lot of different topics, anything from parallel computing concepts, to Bash, to security, batch computing, how to manage data, interactive computing, and other new topics as they come along. And it's supported by NSF Award. So this is the table of contents. We'll work our way through it. So this session is for, like I was saying, anybody who's working on a supercomputer in a Linux environment, and you need a few more skills to manage your files, manage your data, navigate doing things on the system. There's Introduction to Linux. We have some repos that can guide you on that, and we have an introductory webinar on that topic. So go find that webinar if this is a little bit beyond what you're capable of. But here you're probably not a sysadmin. Rather, you're just a student, educator, or user, and these topics will really be useful to use. Beauty is in the eye of the beholder. Simplicity is in the eye of the person who's either done something or never done it before. So if you're a sysadmin person, the topics we cover today, probably like that's what babies use, right? They're really advanced in their Linux skills. But for new people coming onto HPC systems, these are skills that you'll find very, very useful. And so we'll do not only this talk, but we'll also, there's a GitHub repo that has some hands-on stuff you can practice after the talk. But you're going to learn about listing files, removing, no, we're assuming you already know the basics of Linux, listing files, removing them, navigating directories, listing file contents, using cat, and also head, tail, less, more. And you have an ability to use one or more standard editors, VI, VM. You have to be able to edit files on the system you're working on, and then relative and absolute paths. So we'll go through several topics: symbolic links, redirection and pipes, wildcards and globbing, aliases, command history, navigating between directories with Ph.D and Ph.D, environment variables, configuration files. This is what helps you set up the environment you're going to work in, pseudo file systems, and quoting Linux quotes. So let's look at symbolic links. These are, when you do a listing for files in your directory, a bunch of files will be listed out and you'll know what's in there, but you may also want to use a soft link. So when you want to avoid writing out a full or relative path name every time you're using a file or an application, or you want to have a generic executable name that refers to a specific version. So we create a symbolic link. We use the ln command. Remember, on Unix, anytime you want to know about a command, you can just use ln-lh and it'll give you the command details. So you can look that up. We use it with the -s option. Without -s, you'll create what we call a hard link, and that's discussed later on in supplementary material. So the command is ln-s file1 and soft file2. So this is the file you already have, and this will be the virtual link. The nice thing is you can put this in one directory and have your regular file in another directory. So we'll show some of the properties of symbolic links. So I'm in a directory, and again, in the GitHub repo are examples with these samples in them that you can work with. So we have a file in the directory, and I make a soft link file1 and then the soft link. It's a soft link to an existing file, and we do that for file1 and file2. So we look at the contents of file1. and we look at the contents of the soft link file1-soft, and they're both the same. And that's the idea, is that they both have the same contents. And then if you look at the contents of file 2, there's no such file or directory. So that's because we forgot to put anything into file 2 and get it created, but we were still able to make a soft link. So now we put some contents into file 2, and there are contents now in both of these files. It sounds like, why would I want to do that? But it becomes obvious when we show you a couple of examples. So now in our directory, we have file 1, file 2, file 1 soft, and file 2 soft. And now we're going to delete the soft links, and see that we now just have file 1 and file 2. So these are virtual. If you delete the file 1 soft, you don't delete file 1. Okay, they're treated like standalone files. So now we have file 1 is still in our folder. A file can have these multiple symbolic links. So now we're going to make file 1 have 3 different soft links, and they all show up as files, and they would all cat out the contents. So there's no limit, which means you can also put them into different directories, put them in your application. And here's an example of symbolic links can point to directories or files in other directories using absolute or relative paths. They can even span file systems. So on Expanse, we have the Luster Scratch system. When you're running a parallel job, you're probably using this already. And we have an example of a file 4, and we make a soft link to file 4, which lives in this other file system. And yet when we cat out the contents, we can see the contents of file 4. Also, you can also try in a different one with an example that I put in for this talk. Okay, so how do I know if a file is a symbolic link? That's really a good question. ls-f will append the @ sign to the file name. And ls-l shows L in the first column of output and lists the file it points to. So you can recapture what these are. And this is useful for when someone has used soft links inside an application, a configuration file, some other part of the application area you're working. And then you can also use color. That'll auto display names in teal, depending on the environment you pick. All of this will be just in black and white. Okay, so here's a usage scenario. So we have an application has multiple versions. Although you occasionally need access to earlier versions, you normally want to use the latest release. That makes some sense. By creating a symbolic link that always points to the most recent version, you can avoid having to update your job, your script, your code by just updating what the link is pointing to. So this application takes multiple input files, and while one of the files is different for each calculations, others refer to reference data that rarely changes. So we can create symbolic links that point to the latest reference file. And so now we're in some area where we would imagine is an application with a binary directory, and we list this executable cdfapp_v1.1. We have a v1.2, a v1.3. And what we do was we make a soft link to the most current version, which in this experiment is v1.3, and we call it cfdapp.exe. And then we go into some folder where we have reference data, and it's the same thing, version 1, version 2, v1.2, reference v1.3, and we have ref.dat point to the most recent reference data. Now here we envision using symbolic links inside of a configuration file, and or setting some paths in the real-time environment. And I'll talk about both of those scenarios later, but we've defined our path. In Unix, there's the path. Remember, you could do echo $path and see your whole path. But you can add to the path this location to the application bin, and a reference path would be to the reference data. And then you have the alias cfdapp.exe. We made that point to excuse me, the most recent version, and then the reference path for reference data, and then any other additional arguments. And now, no matter how many times I change the current version or my current version of reference data, my command will always work with the newest, latest version. It becomes handy when you're doing a lot of development and testing. So now we're going to redirect and pipe. This is probably the most frequently used command I work with. Well, I work with a lot, but this one is you're going to use it a lot. So the Linux commands write to what we call standard output. When you type onto the screen, you're typing into a command on the Linux environment, and out comes some output. That's called standard out. When you type and that command is read, that's called standard in. And standard in and standard out have a basic definition on all Unix systems. The input goes into the command that you're working with. Like here, date is date is a command, and it doesn't take any input, but it generates some output. And the date would normally just give you the date here, but here we're using a redirection with the right arrow to go to some out file, and the contents of that out file reflect the date. This is really useful when you're redirecting and you need to put a bunch of information into a file. Output can be redirected to a file using a single right arrow or double. Double right arrow will append the output to a file. So if you do date again and you write the out file, it gives you a new date, and that overwrites the content of the file. Here we do append, and now we see a running times that 2 different times. This becomes really useful when you're looking for information in a bunch of files and you need to aggregate them into one. And so you might grep your output file for data with a certain keyword, and then you output that into a data results file, and you had several experiments, and so you can concatenate all that data into one file. And you can use that with this output redirection. You can use this inside of a shell script. You can use it as a system call in your code. But the whole point is that this will run and execute a command and take that output and put it into wherever you tell it to go. And in this case, to a file named out file. And you can name it whatever you want. Another useful command is the pipe. Well, there's two. The word count is very useful for analyzing some of your outputs, but the pipe can take the output from one command and direct it into a second command. And you can pipe a full number of commands, like I use grep all the time to look for the presence of data in a set of files. So the pipe command takes standard out. So here we're doing the file listing -L, so give me full information, date and time and other information. Pipe it through word count so I can count the number of files in my current directory, which is 13. Or I want to look at the 3 longest running jobs running on Expanse, on node Expanse -2-09. So I run SQ, that's the command. I grep, remember grep is looking for a string, and I grep for this string Expanse -2-09. If it's unique, you don't need to quote it or anything like that. We'll talk about quotes at the end of this talk. And then look for the first 3. If you want the last 3, you do tail. So head and tail are also very useful. But here we get the list of the the first listed 3 jobs, 3 longest running jobs, excuse me, on Expanse. Okay, so next we want to do some more about redirections and pipes. Standard in can also be redirected. Remember, when I run a command, the output goes to standard out. When you type stuff in, that's called standard in. And this is sometimes useful if you want to prevent a command from listing the name of the input file. In the example below, we look at piping the output from word count -L, and look at the output that includes the file name, and it counts the number of files. And now here I take the file1.txt and I use the cut. I just want the line count, and from that I get the line count. And here it contains, again, just the line count for redirecting the contents of file1 into word count. All right, next we'll look at wildcards and globbing. Wildcards and globbing. So wildcards let you develop a pattern. This is regular expression. And if you've taken computer science classes, you may have had to plow your way through a full regular expressions class. But it's a way to express a pattern for matching multiple file names, for example, giving any combination of the following. Question mark matches any single character. Star matches any string, including the empty string. And dot, dot, dot matches multiple characters inside the left and right bracket. And it could be a multiple characters or a range of characters. And anyway, globbing is this operation that expands that pattern to a list of files. It's done automatically by many Linux utilities, and it can operate on files that are operate on files using commands such as ls, rm, mv, cat head, tailend file. So here we have an example of many files inside the directory. We have different names. Some are text, some are executable, and they begin with different letters, and they're all about the same length, but that's not really a pertinent fact. So let's look at all the files, all files that begin with file star. Not all files begin with them. So how many? Here's the listing: file 1, 2, 3, 4, file A, B, C, D. List all files that begin with F star, and that brings in F, G, I, J, and files like that. And if we just, if we want to just look at files that begin with any letters, have GHI in the name, and end with any letter combination, that pulls out 3. So you can use these characters to find different file names and select different files. So now again, we're using the question mark symbol. So now ls all files question mark dot dat. So that's the file and then any character plus dat. So file, that's effectively the same as file star dot dat. And that gives us all file any character dot dat. And then we could list anything beginning with an A, and then has some letters, and CDE dot star, any ending characters. So that brings up two files. So we're a little more restricted in what we're pulling out on this command. And then ls star, so question mark, question mark, question mark, question mark, dot, question mark, x. Any 5 characters, because there's 5 question marks, plus the dot, plus any character, plus x, plus any character. And so this gets us 5 characters, A, B, C, D, E, dot T, dot E, an X, and then another character. So question mark represents 1 character as opposed to the star would be any number of characters. And then wildcards and globbing using left and right bracket character matching. So here's our files again, same set. And now ls file 1, 3, right, left bracket 1, 3, right bracket dot dat. Multiple matches using anything with a 1 or a 3. So we got file 1 and file 3. And now 1-3, 1 through 3, which would be 1, 2, 3, and that brings in file 2. Or left bracket AC, right bracket X star dot star, multiple matches using this list of 2 letters. So AXCD, there's an A and a C, and there's an X. So we're getting any combination. CXEFG, same thing, beginning with C and X, and then anything after that. And then A through C, we get A, C, B, XD, C, XE. So you can play with these to pull out the kinds of information that you want. You might wonder, well, why would that be very useful? I've seen like physicists that run large experiments where the names contain like 80 character long names, and in it were the date, the time, the experiment number, a name of the experiment, a huge amount of information in the file name itself. And in that case, extracting out a particular experiment that they ran where they want to pull out everything on a certain date or with a certain keyword in the test type, then they would be using this kind of wildcard and globbing. Okay, so now we come to something that's really important is aliases. So they're shortcuts for Linux commands, and they're useful for keeping you out of trouble or also abbreviating a complex command. I use aliasing all the time. I have an alias for logging onto machines, but this is a really important piece of information. Alias rm equals quote rm dash I end quote. So whenever you try to remove things, you will be asked, are you sure you want to remove this? This is really important. Put it into your configuration files, which we'll talk about in a moment, so that you're always executing this in a safe manner. There is the classic story of somebody who deleted everything. And if they didn't back up their files, then they're in trouble. So be very careful when you use remove and put this alias in. Excuse me. All right, so abbreviating a long command is really important. For example, here's a neat alias is look at the partitions in the Slurm scheduling server. And if you've taken introduction to batch or basically HPC concepts, you know that you use a Slurm batch queue system to run your jobs. And if not, you want to learn about that. So we're running sinfo-o, and then this is a Slurm info command. And then there's a whole lot of information that comes out, and we're going to tell it, take the output from sinfo, but display it this way. This addresses each of the different fields. And then if you do which partitions, there's our partition right there. And then you can run that and see what the output looks like. You can alias anything, reservations, the remove, spactivate, BI, and again, these are just some examples of what the authors of this talk. In fact, Bob Sinkovitz is the main author of this presentation. So anyway, you can make any aliases that you want. I alias my commands for logging on. I have like 8 accounts on 8 different HPC systems at SDSC and throughout the country. And so I alias so I could just say expanse, and that will automatically log me in. So you can find all kinds of interesting uses for aliases. It's one of my favorite commands. All right, command history. What have I been doing and what happened? When was the last time I did something? If anybody has done a lot of testing and debugging on any Linux system, it's easy to have like thousands of things that you've done in the past. And trying to figure out when was the last time my command actually worked, like if you're debugging, then history becomes a very, very, very valuable tool. When you type history, and this is a commonly used term when the output is so long, I can't fit it on my presentation. I snipped the earlier, but in this one, there's been at least 430 commands in this current Unix session. And history, you can tell it how many commands back you want it to save. And the last thing run was echo hello, but we also we removed a file, and we also listed all the files that ended with star text. So why is that important? Well, let's say I want to do it again. I just do bang, bang, echo hello. So the exclamation point, I'm old fashioned, I call it bang, bang. It will go back and find the most recent command I executed and run that, hello. This becomes really helpful when you're like your compile command is 35 words long. You just find that last command and you can go do, run that command. So let's say we execute the last command that started with an ls. You can do bang ls. That would have been ls file star.txt. There it is, and out comes the right output. Or execute a specific command like 428, listing the files. So you can go back and say, well, I listed 85 files, so just asking for ls is not enough. I want the ls where I listed files that were on the scratch partition for my output data. Very powerful concept, this recalling and knowing your command history. It will save you a lot of work in the future, like not having to retype a 32-word long command. All right, so we want to be able to work in multiple directories, and there's this concept in Unix called the stack or operating systems, and the pushd and popd will create a directory stack. So you can move through different directories and keep track of where you are and get back to somewhere, another directory pretty quickly. Instead of CDing back home and then CDing back down into a project, you just put it on your stack and pop it off when you want to get to it. So pushd will push the directory into your stack. And once you push a directory, then it lists the most current item in the stack. It's reverse listing. And so you can see the stack, the directory locations that are in your stack. So we're going to push another directory onto it. Push d dir dot dot dir 2. So now you're in directory 2, and you came from directory 1, and you started out in ppdem. So it moves you and then keeps track of where you've been. And so I'm going to go to a new directory, dir1, and now pushd is listing the directories I'm in. I can push d plus 2, which moves me to ppdem. So go 1, go 2, go back to ppdem, but the other directories are still in my stack. And then dir.s tells you all the lists of your directories. In fact, you can type, the dir.s will tell you what's in your directory listing. And you can pick one that you want to go to, which it will take you there. And then popd plus 1, go to dir1. So you get in there and play with everything, and then it starts to make a little more sense. While you're making an application, for example, here's a concrete example. We want to alternate between modifying and testing the code to keep our work organized. The code development and execution are done in separate directories, which is often a smart thing to do. Keep your code base in one directory and your output and testing in another one. So use pushd and popd. That allows us to easily move between the two. So we went into the code directory, we edit our code, we build our directory, and we push ourselves into the run directory. Then run the code and examine the output. Then what directories do I have in my stack? So it confirms that there's 2 directories in the stack. And I'm going to push D, so I end up in the code directory, and push D, and then I can run code again. I recommend you write your own notes about what you think pushd and popd are doing, and make sure as you're running it that you play with it. It takes a little practicing to get comfortable, but once you start using it, you go, oh, this is pretty cool to move around to all these different directories without having to retype them. I just push 1, 2, 3 and move around. Environment variables, again, shell variables are really important, and environment variables are important as well. When you took Introduction to Linux, you were taught the env command. If you type that, a big spew of data comes out, often 100 lines long, showing all the environment variables that you're using, or shell variables that are available for you to use, like $home, that's a environment variable. And so they allow you to customize your work environment and control how your applications and everything you're doing are working. So the shell variables are only known within the current shell that you're in. Environment variables are known globally and are inherited by processes and shells that are launched by that current shell. You generally want to use environment rather than shell variables. There's times when you're in a shell and you don't really need it and you don't worry about it, and then you exit that shell. When you log in, you land in a shell and it's populated with environment variables. And when you move to a new shell, we'll show you examples. You get those same environment variables that are global. They're set using key value pairs. Key, the name of the variable you want to set, equals value 1, 2, and 3. Space is not allowed, the equal sign, and by convention, the key is capitalized. It doesn't have to be, it's up to you. They're made into environment variable. Shell variables are made into environment variables using the export command. And there's times when you end up temporarily creating a variable and you export it to the command that you're trying to run. The values of the variable are accessed using the Unix $sign key. So the keyword, the title, the variable name, and the $sign will get the value out. You should be somewhat familiar with using the $sign from Introduction to Linux. So here's an example where we're making two keys. One is ABCD, the other key is EFGH. Notice those are inside quotes. Not always required to do that, but it's smart to use quotes around variables you want to define as a string. And now we've set these two shell variables. Now we'll export key 2 and export key 3 equals IJK11, IJKL, excuse me. So notice you can combine these two steps into one. And now we're going to echo the value in key 1. We see ABCD, EFGH for key 2, and echo key 3, IJKL. So now we're in one shell and we're displaying the values. Now, whoops, sorry about that. When I type /bin/bash, I'm launching a new shell. And you'll see that you're still in your terminal window, but you're actually in another shell. And we try to echo the value key 1. It's not, there's nothing in it because it was only known in the parent shell. But we exported key 2 and key 3. So echo $key2, EFGH is now inherited, so you can use that data inside this new shell. And echo $key3 does the same thing with key 3. What's the value of this is when you're submitting a batch job as a batch script, you might pass variables to that batch script and then use those variables inside the script. And when you run that on a cluster node, that script launches and inherits shell variables. And then if you're running it on multiple processes, those processes need to inherit shell variables, environment variables, so that all of your processes can share data. It becomes really powerful once you think about the need to have data shared without doing file IO, like opening a file and reading in data. You can just pass this data from process to process. The variables can also be set with the declare command using the -x flag to export and -r to make it read-only. For example, you don't want that variable changed. So you declare this variable, var1 equals ABC, declare -x var2 equals DEF. So this X flag to export, and echo var1 and echo var2. And now remember the -x is exported and read-only. So echo $var2 is DEF. So now for bash, we run bash and we echo var1. We didn't export it, so there's no value. And we did echo $var2 to get the right value. I also added a little command in this instruction, which would tell you what shell level am I in. So we went into a bash shell, but sometimes you go bash and you go into other shells, you might be 2 or 3 shells deep, and you don't know how, if I keep exiting the shell to get out of it, you type an exit command, you might get logged out. That terminal exit has happened to me before. So you can say, how many shell levels am I in? And it comes back with 2, because now I can type exit. I'll go back to my original shell, which in most cases, that's your login shell. So I just threw that in as a piece of additional information. All right, so the environment variable, you all know about this hopefully from using Unix in the past and taking our training, but if not, it gives you all of the environment variables that you've got. And starting with the path, where are things located, executables located, that would be used for running things, the libraries that might be used for compiling, and you want to make sure those are updated, and the manual paths, so that for certain commands, they do have man pages and you can look at how they work. Modules are also, your login name, the shell you're using, and where is your home. These are just, there's a big snip around the rest of the data you would get from the env command. Okay, all right, now configuration files. We're doing good on time. Linux has a number of configuration files for customizing your environment. and we'll try to unpack this for you. It can be a little confusing, but when you log in, these get executed for you in a specific order, and it gives you your login name. It gives you the information about your home directory. It builds out all kinds of information, and you can add anything in there, like customizing the remove command. So there's a lot of ways that you can customize your environment from the moment you log in and then when you launch a shell, for example. So etc profile and etc-rc, these are built by the system administrators of the system. You can't change them, but they do get executed every time that you log in. ~/.bash_score profile and .bashrc are in your home directory, and you can customize them as much as you want. Yeah, and you can put in links to libraries. You can add to the path. You can add to the listing of other aliases that you might want to have. So it's a little confusing at the beginning, and these are for bash. And if you're in a different kind of shell, there'll be similar files that define your launch environment. There's also this hierarchy, and they can execute these other scripts that you might link to them or are linked to you by the system. We'll look at that in a moment. It can just be a little confusing. You can usually get by customizing environment variables in bash profile and put aliases and functions in .bashrc. Just standardizing where you're putting things will make it easier. When I did a master's in computer science, I did Java. I was installing on my own because I didn't have it. I probably had 100 libraries I was installing, 50. And every time they changed versions, I would have to update things. So I got to really appreciate aliasing things. Anyway, there are lots of reasons you're going to learn and want to learn this. Often when you adapt some program like I was doing from your collaboration group and you install their software, you might have to define paths based on what that requirements are for that application. It's not at all unusual. And just realize if it gets confusing, reach out to consult because we know it's confusing. And we can find illogicals or maybe typos that if you don't get it right, it can make it hard to even log on. So go to, let consult know if you're having trouble because you've been messing around. It's always good to make a backup of things for like a .bashrc underscore profile, a .bash underscore profile that worked. Then you started making changes. It's good to have backups. All right, the interactive shell and non-interactive shells are different. Interactive shell is the one that the examples I showed you, you log in, you run some commands on the terminal. That's interactive. It's real time. It's reading and writing to your terminal. If you can enter commands, you're in an interactive shell. There's interactive login shell. It's launched when you use SSH to connect to Expanse, for example, or to connect to a node that's been assigned to you, like through Galileo. That's where you'll usually work. A non-login shell is launched from a login shell by executing bash at the command line or opening a new terminal from your Linux desktop. Or it could be launched inside of a batch script that you've written. The non-interactive shell is not associated with the terminal, usually launched by a user executing a script like the batch script. I was incorrect on that. Okay, so here's sort of order of execution. What happens first? When you log in, the stuff in your home directory is not touched until you've been validated by a security process and then this etc profile launches and it runs some commands to build out all of your environment. And my first comment to new users is, yes, it's very complicated. And yes, one day everything you've written is running, and the next day you might log in and nothing is working because there may be something wrong with all of these different programs that get executed. There might be something that changed in a library that you're using. We know it's complicated. So just getting in and making sure you can log in and do a listing on your files, a tremendous amount of work gets done through these different codes. Like I said, these ones you can't change. You can look in them. You're welcome to look and see what kind of environments or variables are defined for you, for example. But then your bash profile and .bashrc files get executed. Normally they're operated in this order, but it can change depending on the OS system that you're using. And so be prepared for it to be a little bit different every time. But if you know where you put things, you know what kind of changes you made, you can track your environment. And just reach out to the consulting team on whatever system you're working on. If you don't understand, like you defined an environment variable, but it's not showing up, realize that we understand it's challenging at the beginning. So for this, the legend is these are system-wide configures, and then they execute user files. Um, okay, so this diagram is not to scare you. If you look at and think about how complicated the system is when you have 100, 13 racks and, 75 to 100 nodes and multiple CPUs on those nodes or GPUs, it's a big system. And so when you come in and you try to run a remote shell or a normal shell, for example, you can follow this tree down to all the options. It just is like, oh, why should I even look? For the curious, it's like, oh, that's how that happens. But this is just really complicated, and don't worry about it. If as long as you can get in, then everything is working and your bash scripts are doing fine, and the sysadmin people are keeping everything running for you. The good news is if you're using bash and you're not a sysadmin, you never have to go in and worry about all those files. You just worry about these two files and make sure the environments that you're building in them are working and you're updating them appropriately, getting the right path. And on Expanse, just getting the right path can often be complicated. So use configuration files.bash profile. Use it for commands that should be run only once, such as customizing an environment variable or setting your path. You don't want to run it again and again and again. Don't touch these top lines here. This is what starts things off. Just leave it in there, and this is what the sysadmin people have put in here. When the system version of a bash, the system bash profile runs, then it goes here and it looks for these lines. And you may get logged in, but you may not have anything that you think you need to be executing this local.bashrc. So you want to make sure you do remember to do that. Okay, so in this first, these are your paths that you're adding to. Like here, I'm adding Anaconda. I've added my own directory that I might have my own binaries in, and I'm adding something to do with profiling AMD. And it's the full path. It's not in my home directory, but I have it in my path. And what that means is when you try to run an executable, the system will go through your full path. It will look through all of your path and make sure that it can find like the AMD profile command. And if it can't, it won't work. But paths can be very, very, very long. There's an order that it gets traveled. And so you want to make sure the right things in your path are set up properly in this file. The .bashrc, it's for commands that you would run in every shell, like an alias. So that every time you launch a new shell or a new project that launches inside a shell, your aliases are there. And also, we have talked in the past, if you've taken other training, about the module system. This is where a lot of the intelligence comes into your work, like load slurms so that you can use the slurm scheduler system or load the default SDSC environment variables. So this is, again, things that you want to run in every shell. Okay, pseudo file systems. Following the Linux philosophy that everything is a file, an image, an executable, a directory, a file in a directory, everything is a file. So we have pseudo file systems that allow you to access dynamically generated content. And they are in these two interesting folders called /proc and /sys. You might want to know information about the GPU in the system you're running in, and that's something called CPU info. But it's in a directory called /proc. But you might do a listing and see that there's CPU info and version, but there's nothing in it. Oh, wait, this isn't right. But when you run it or look at the contents dynamically on demand, CPU info will be provided to you. And it's got 99,000 lines in it. So you might want to be really careful before you spew that onto your terminal. or for the version, it's a little bit smaller. It's only 186 lines. So if you're feeling you can look at any of these, you're welcome to. That's an open, accessible folder for you to read. You don't have right permission. Read, read, read. Only sysadmins do. But be careful looking at them. You're not going to hurt anything except you might spend several minutes watching 99,000 lines scan by. So this is a guidance to check how big the file is that you want to look at. Again, you might cat it and grep for CPU to see if it tells you once you get an idea of what's in this actual file. Okay, and so the ls CPU command interrogates the system and figures out what do we know about the CPUs, and it organizes the results. And it's very big. There's a lot of information in it. The model, number of sockets, number of cores per socket, what kind is it, x86, what flags does it accept? There's a lot of information in there. And here in this next slide, we highlight a few that are of relevance and interest to a typical user. So we're on an x86 architecture with 64 core AMD EPYCs, 2 of them on that node. So there's 7,742 processors, and hardware multi-threading is turned off. The CPUs are organized into 8 NUMA nodes, et cetera, et cetera. We have the L1, L2, and L3 data caches. So when you're getting down into the deep weeds of debugging, knowing the size of the cache, and that's the rate at which I'm able to feed data into the CPU, might become important to you. But if you want to, know more about this, you can also ask Consult for help. So this one highlights the AVX and AVX2. These are the flags that are you can pass flags to your compile command or to the executable, and these indicate the kinds of instructions that are available to accelerate or enhance your coding. And go to the Expanse user guide, for example. These examples are on Expanse, and look for information about these flags, and they're explained, or the links to the information are in the user guide. So getting memory, proc mem info gives you the information of a regular memory node on Expanse, or a large memory node, or the GPU node. All right, and we'll wrap this up with Linux quotes. So you have to tell Linux, because everything is a file and everything has some computational value. You want to tell it when you're making a literal value and it's just a string, and the numbers inside of it are just part of a string as opposed to an operation. And the double quotes also allow you to further enhance your definition of a string, and also to recognize certain key characters like the $sign, the single apostrophe, the backslash, and the exclamation point if history expansion is enabled. So here we're going to export a couple of values and then concatenate those with the plus sign. In this case, since this is a string and that is a string, the plus sign could be an operation, but we don't want that to be a math operation. So we put single quotes around these two variables, and echo this value. So it just writes out $var1, $var2. It didn't give me the values. The $sign, because it's in the single quote, everything in here is a string. Now we're going to try and extract the values of these two strings. So we use double quotes, allows the $sign to be an operator, and extracts ABC plus DEF. The plus sign is still a string. So again, when you're in this environment where things can be an operator, like in this case, the $sign doesn't mean dollars. It means it's an operator that extracts the value of that variable called var1. So sometimes playing with strings and quotes and backslashes gets a little tricky, but you'll figure it out. Lots of examples on the web for all the stuff, by the way, covered in this talk today. There's hundreds of really good Unix, Linux command web pages with, man pages on each of these. So Here's another example. If your strings don't require any special characters, you can use single and double quotes interchangeably because you're not confusing the system with, is this an operator? Is this an operator? It's just all strings. So double quote, good morning, Bob, single quote, double quotes. It prints out good morning, single quote, Bob, single quote. Or single asterisk, single quote. Sorry about that. So here's another example. We've put the single ticks around Bob in double quotes, and double quote Bob double quote is treated as just characters in a string. But if we wanted to extract something, we could say backslash ignore these, and of course we still see the same thing. But here we're going to get a little bit of operators to backslash, $, bar2, backslash. So what is going to come out is it's inside double quotes, and this operator says ignore the character after, so we don't see that one, but we get one. And then we still have this single string because it just gives us one character. So playing with the ticks is kind of interesting. The backticks are different from the single double quotes. Single double quotes apply mostly to characters. The backticks indicate executable. So if you're on the command line, you type, for example, me equals backtick, who am I, backtick. Who am I is actually a command, and it will give you back some information, just like date. And I take the backslash date, backtick date, backtick gives me the date, and I store it in a variable called date. And if I echo $me, I get all this information about user sync of it and some other information. If I echo $date, I get the full date. So inside a script, it's very useful for capturing information that will make your script run better. Playing with ticks and quotes and things like that is quite exciting. All right, so in summary, we've learned some intermediate Linux skills, and we hope these will help you to become a better, effective user. You're able to do a little bit more with the commands and the scripts that you're running. And you can use these inside a batch script, which you're learning to build if you're running jobs on the batch script, the batch queue. And we've given you some tools. We've covered most of what we think you should need to know. And there's all kinds of other resources for different Linux commands. Again, find a couple that work for you and just bookmark the page that gives explanations in ways that you can understand. There's online places where you can cut and paste. And here's a couple of links to advanced batch scripting, and then Linux forums, and probably Reddit has several. Okay, and with that, we're done. And that's supplementary material. So with that, I can stop, and I'm assuming Bob and Marty and Nicole have been answering any questions, but anything left you want to ask me or them? Again, Bob is the original author, so compliments to Bob for thinking up this tutorial.